Thank you. Welcome. Like yesterday, we had done some exercise. I want to make some correction. If we continue, let me begin with this number. We had the number 1 and number 2. I'm making correction, so be there, watch. We say we had received the number 1. The diagram below shows a lever, and you saw the illustration. So we're beginning with A, where I've said, what is the weight of K? Yes, once more, we're here. Like I left you with the activity for lesson 1. We have to make correction, of which I've displayed here, and you need to follow these steps such that you find the best answer. We had the number 1, which I've explained, like we said, the clockwise moment is equal to the anti-clockwise moment in relation to the principle of moment. You can follow. Hope you're watching. This was A. And when you come to B, the center, where there is Q. Q is a program, like you have seen. Okay? Come to number 2. We have to find X, that's joy. Can also check through. Right. Yes. Once more we're here. In lesson 1, we had 2 activities. Beginning with the number 1, like you have seen the illustration. We said, following the principle of moment, we find that the load, which is 50 newtons, times the arm, which is 10 meters, and then is equal to effort, which is K, times the arm, which is 25 meters. So when you follow this, you find that 50 times 10, this is the clockwise moment, is going to be equal to K, which is here, times the arm, which is anti-clockwise moment. You will get 500 here, which is equal to 25K. 25K. And then when you get 500 is equal to 25K. We must make K a subject by eliminating 25. So we're going to get 500 divided by 25. And then 25 divided by 25. Whereby 25 divided by 25, we are going to get 1. We get 500 divided by 25, whereby we are going to get 500 divided, 25 divided by 5, you get 5. And 500 divided by 5, we are going to get 100. Then 100 divided by 5, we are going to get 20. Therefore, our K is 20 newtons. We are following the units. In case they would have given us here kilograms, then we would have used the kilogram. But because the unit here is Newton, we have also used what? Newtons. That's the number 1A. Number 1B, we are looking at the name given to this part here, the turning point, is the program, like you have seen it here, right? Then when we come to number 2A, we have to look for Joanne's weight. Joanne's weight is missing. Shall follow the same procedure like we did in number 1. We have got the load on the clockwise moment, where we have 120 kilograms multiplied by load arm, which is 4 centimeters, yes? It is going to be equal to the anti-clockwise what? Moment, which is 40 for the first part of it. Remember, Joanne should move from this distance, 6 centimeters, and also 2 centimeters to reach the program. So Joanne moves from here to here. So So when you are calculating Joan's distance, you need to know that she is moving from the center up to the point of her weight. So we're going to begin with Brian, who's in the middle of Joan and pivot. Shall say 120 times 4, which is the arm. Yes, on the number 2. And we're seeing where we need to find weight for Joan. But remember, Joan is moving this distance, A and B, while Brian is only moving this distance, A. So we should find the weight of Joan, considering the distance marked 6 centimeters and distance marked 2 centimeters. Now remember, we said the principle of moment is moving like this, or states the sum of clockwise moment is equal to the sum of anti-clockwise moment. And this is the method we have used, where we have said load force times load arm, the force which is 120 kilograms, and the arm, the distance, which is 4 centimeters. So we shall say 120, the arm, I mean the force, times the arm, which is 4 centimeters. On the other side of effort, we're going to see effort where there is X and where there is 40 kilograms for Brian. But our interest here, I want to find the weight for Joan. So we're saying effort, which is the force, times effort, which is the arm. We're going to say 40 times 2 for Brian. 40 times 2, the force and then the distance. While for Joan, we have got X, whereby we should get X, and therefore shall put the distance A and B in the brackets to get X. So we shall say 120 times 4 is going to give us 480. And for Joan, we are going to get 80. Whereas Joan shall get X times 2, which is going to give us 2X, plus 6, X times 6 is going to give us 6X. Therefore, shall come here and say 480 is equal to 80. This is for Joan, for Brian, plus 8X, that's for Joan. I'm going to find X. So to eliminate 80 and remain with the 8X such that to make X the subject, we shall say 480 minus 80 is equal to 80 minus 80 plus 8X, which is going to give us 400 after subtracting. 480 minus 80 is going to give us 400. But we shall make sure we divide each side by 8 to remain with X as a subject. So we shall say 480 divided by 8 is equal to 8 divided by 8, so that we remain by X, with X. So 8 divided by 8, we are going to get 1. We'll get 400 divided by 8, whereby we're going to get 8 divided by 2, we shall get 4. Then 400 divided by 2, we're going to get 200. And we get 200 divided by 4, whereby we're going to get 50. Therefore, 50 is going to be equal to X. But we are looking for X. Therefore, shall we say X is equal to 50 kilograms. Because our units here, they have not given us Newton, they have given us kilograms. And therefore, the units here should be in kilograms. But the question was, what is the weight of Joan? Therefore, shall say the weight of Joan is 50 kilograms, and then we underline. That is for A, number 2A. Number 2B, it is saying how far is Brian from Onisima? How far is Brian? This is Brian from Onisima. Onisima is sitting at this point of 120 kilograms. So we shall say 2B you get the distance of Joan, of Nisima from the program, plus the distance of Brian from the program. We are going to get 4 centimeters plus 2 centimeters. This is going to give us 6 centimeters. But I've said what is the distance? How far? So we shall say Brian is 6 meters from Nisima. Brian is 6 centimeters from Nisima. That is correction for our activity for lesson 1. For today, we want to have something different from this. When we talk of machines, there's calculation, we have what we call mechanical advantage. Each machine has got what we call mechanical advantage, mechanical force. Hoping we are together there? Yeah. So we are saying we want to do something related to what we call mechanical advantage. What does the word mean, mechanical advantage? When we talk of mechanical advantage, you are saying is the number of times a machine simplifies work. A number of times a machine simplifies work. Number of times a machine simplifies work. I can also say is the ratio of load to effort. The ratio of load to effort. And this one will give us the formula, the short unit of mechanical advantage. We are going to say mechanical advantage is equals to load out of effort. Load out of effort. Let us use this example. Example 1. We say Kutos lifted a sack of flour, maize flour, 90 kilograms, using an effort of 30 kilograms. What is the mechanical advantage? Because yourself as a human being, a machine, right? find mechanical advantage. Shall say mechanical advantage is equal to load out of effort, whereby our load here load is 90 kilograms and effort is 30 kilograms. But mechanical advantage here is not known. Shall say mechanical advantage is equal to load out of effort. Our load there is 90 kilograms. Shall say mechanical advantage is equals to load which is 90 kilograms out of 30 kilograms. But remember, mechanical advantage here is not going to have a unit. Therefore, shall say kilograms and kilograms will first disappear, but that remain with mechanical advantage is equals to 90 out of 30. Right? 0 and 0 will disappear, such that will remain with 9 divided by 3, whereby our mechanical advantage is going to be 3. We have already got the mechanical advantage. That's example 1. I would wish to give you more examples, but let me give you this activity. When you try it and you see there's a difficulty, then try to contact me on the other telephone number you're going to send the screen from further consultation. Try this. Number 1, find the mechanical advantage I used the load of 100 newtons to lift used the effort of 100 newtons to lift the load of 200 newtons. B. Used the effort of 100 kilograms to lift the load of 50 kilograms. So when you try these numbers out, you'll find that work becomes simple for you. By the time we meet, we shall add on more examples and other exercises. May God bless you as you watch and follow.